Hello students, I welcome you all in my lecture on virtual functions in C++. Let us start from the need to have a virtual function. The virtual functions is a mechanism through which we can achieve runtime polymorphism in our programs. If you recap the concepts that we were studying at the time of polymorphism in my previous lectures, we have discussed two types of polymorphism. One was the compile time that can be achieved using function overloading and function overriding. And the second type of polymorphism is known as runtime polymorphism that can be achieved using virtual functions. Virtual functions is a concept of calling a function using a pointer rather than using the object reference. And it can also be used to create an abstract class. So before we move towards the virtual functions, we try to understand the concept of abstract class. So an abstract class is a restricted class that cannot be used to create the objects, which means that you cannot create an object of the abstract class. This is a class that contains an abstract methods. Another definition that we can easily found is, what is an abstract class? We say an abstract class is a class that contains an abstract method. So now we look into the concept of abstract method. What is abstract method? Abstract method is a method that is declared but it is not defined, which means we are going to simply going to declare the method and there will be no definition for this particular method either within the class or outside the class. So there is only the definition and there is no, only the declaration and there is no definition for the method. An abstract class may or may not contain an abstract method, but that this is not the case in C++. In general, the object oriented paradigm state that an abstract class is a class that contains an abstract method, or simply it's a class that does not allow us to create its object. So in most of the languages we have a keyword that is abstract, and whenever this keyword is used at the time of the definition of the class, it makes that class abstract. But in C++, there is no concept of any such abstract keyword. Therefore, specifically in C++, we need to add an abstract method in the class so that the class can become abstract as well. So the class may or may not contains the abstract method, but on the other hand, the class may have a non-abstract function. For example, a class contains 4 functions, out of which 3 functions are defined and we have only one function that is abstract. So that one function will going to make my class abstract. So a class can contain different types of functions, multiple functions. Out of them, we may have or may not have any abstract method. If the method, for example, if we have some abstract method, which means my class will also become abstract. As you discussed that some of the languages uses the keyword, but in C++ we don't have any abstract keyword available. So we need to add the abstract method, and one of the way, or we can say the only way to add the abstract method is the use of virtual function. So what is a virtual function? Simple, very simple. A function that is declared using the virtual keyword is known as a virtual function. To use the concept of virtual functions, always remember we need to implement the inheritance within the classes. Why? Because we are going to declare a function in the base class without any definition so that the class can become abstract. But we cannot execute this class because it's an abstract class. We cannot create the object. Therefore, we need to inherit from this class a new class, and in that drive class we are going to define the definition of this particular function, which means to make it simple, always remember that the virtual functions can be a type of functions that are declared in the base class and they are defined in the drive class. So for the virtual function, it is mandatory to be overridden by the drive class. So these type of functions are mandatory to be overridden by the drive class. Otherwise, your drive class will also become abstract. Just focus on the concept. You have add an abstract function or the virtual function within a base class. You drive a new class, that is a drive class, and then you need to provide the definition. If you omit the definition from the drive class, the drive class will also become abstract. So it is mandatory for the virtual functions that they must be overridden by the drive class. Third property of virtual function is that they are always called using an object reference, which means using a pointer rather than the object itself. We cannot use the dot operator, like we cannot use object dot function. We need to use some pointer to call these virtual functions. Till now we were dealing with the non-virtual functions, which are the normal functions, and normal functions you all know that can easily be called using the dot operator. But this is not the case with the virtual functions. These are some special type of functions which are going to be called using a pointer. So now just remember and try to make an image in your mind that now we have a function that is declared in one class and is defined in another class. So at the runtime, the virtual function will going to ensure that the current function is being called using some object reference, that is your pointer. So the resolving of function call will be done at the runtime, that is known as the late binding, and this is how we are going to achieve the runtime polymorphism, which means by just viewing the code at the compile time we are not able to identify which particular function will be called at runtime because the function is called using a pointer. And for example, the pointer is null, or for example, if we don't know what is going to be the address of the pointer, we are not able to confirm the call at the compile time. We need to execute my program to ensure which particular function is called at the runtime. This is basically the concept of runtime polymorphism that is achieved using virtual functions. Now look into the rules for the virtual functions. First, they must be declared in the public section of the base class. Remember, you need to make them public because whenever you are going to perform inheritance, the public area is always inherited to the drive class and it can be easily accessed using the drive class. Therefore, it is mandatory to make these functions as public. Remember, you cannot make these types of function which are the virtual functions as static. You cannot declare them as friend because they are not friend, they are part of the class, they are part of the hierarchy, and they will be accessed using the child class. So you cannot make them static, because if you're going to make them static, you all know that static member functions will be kept with the class itself. Only one copy of the function will be created. So whenever we are going to inherit, these will not be going to forward it to the child class. So it cannot be static, it cannot be friend. These functions are always accessed using the pointer. We are going to use the pointer. We cannot use the object for calling these type of functions. Okay, there is one another rule that the type of the pointer should be of base class. That point we will going to discuss further. But remember that this is a mechanism through which the parent can access the child. In the inheritance, we have seen that the child can access parent, but parent cannot access the child. It cannot transfer call towards the child. But using the virtual functions, we can demonstrate, and we are going to observe that the control can be transferred from parent to its child, and that is basically the one of the features provided by the virtual functions. Because the drive class is going to override the function, therefore it is mandatory to use the same prototype, because we are going to override the function in the drive class. So because we are going to override, which means we need to use the same prototype. Always remember that they are declared in the base class, and it is mandatory for the child class to override these functions. So if you focuses on the rule, always remember there are 3 to 4 points that we need to consider whenever we are programming for virtual functions. First, they must be declared in the base class, and they are defined in the drive class. The declaration must be public so that it can easily inherited by the drive class. Secondly, we need to override, it is mandatory for the class, the drive class, to override all the virtual functions which are declared in the parent class. And because we are overriding it, we are redefining it, therefore we should use the same signature or the prototype for the functions. Remember, we cannot make our constructor virtual. Why? You will going to understand by the end of the lecture, or in the next lecture when we are going to discuss the concept of virtual constructor. You will be able to know what is the reason. But for the time being, remember that you cannot create a constructor that is virtual, but yes, you can create a destructor that is virtual. So you cannot declare your constructor as virtual. Okay, moving towards the type of virtual functions, we mainly have two types of virtual functions. First, pure virtual. The pure virtual functions are the functions which are abstract in nature, which means they are just declared. the functions which are declared but does not have any definition. So pure virtual function is an abstract function that is declared but not defined. This is the syntax. We are going to use the virtual as a keyword. We just need to add virtual as a keyword before the definition, before the declaration of the function. After virtual, we are going to provide the prototype, and after the prototype, we are going to assign 0 to this function. That means that this signature will going to convey compiler that this particular function is only declared. The 0 will going to convey this message to the compiler that this is a pure virtual function. We only have the declaration of this particular function and there will be no definition anywhere. That's why we have declared this as 0. Why we need to declare it as 0? Because C++ normally follows a style of coding in which we declare the functions within the class and we provide definitions outside the class. Therefore, if you are going to declare a function without assigning a 0, the compiler will think that this function will have the definition somewhere outside the class. So we just want to make sure that there is no definition available anywhere. Therefore, we are going to assign 0 after the prototype. So that means we are going to use the virtual keyword. Then we are going to define the return type, name of the function, list of the arguments, and after the closing round brackets, we are going to put equal to 0, which means this is just a declaration and there is no definition available anywhere. The second type is known as a partial virtual function, a virtual function that has the definition as well. So now we have two type of virtual function. One is known as a pure virtual, second is a partial virtual. Pure virtual mainly means a function that is just declared, not defined. This is your abstract function. On the other hand, we have partial virtual function, which means it's a virtual function but with some definition as well, which means this is a function that has the definition within the parent as well. But for the child class, because it's a virtual function, for the child class it is mandatory to be to override both type of functions, either it's pure or it's partial. But remember, the pure virtual function will be treated as the abstract function and will make your class abstract. In this example, we have tried to compare the compile time with runtime or simple early binding with the late binding concepts. We have declared a class base which contains two functions. One is print, that is virtual, and second is show. That's a normal member function, which means a non-virtual function. We have started with the partial virtual so that it could be easy for you to digest the concept. So again, carefully look at the base class. We have two functions. One is print, second is show. Print is virtual function. We have put virtual keyword at the signature of the function, and show is a normal member function, which means a non-virtual function. Okay, on the right side you can see another code, that is a class derived inherited the base class, which means now we are going to declare a drive class, and the drive class is going to override both methods. So we are going to override the print method. And remember, whenever we are overriding the virtual functions, we need to remove the virtual keyword from its overridden version, or simple the definition. We need to remove the virtual function from the definition in the drive class. So the drive class will not going to use any virtual function. So the drive class has overridden the print, and the drive class has overridden the show method. So now the drive class has overridden both the method, both the virtual and the non-virtual functions. So now the drive class has its own implementation for print and for show. Now the base class has two functions, and both are being overridden by the drive class. In the main, we are going to create a pointer of type base. We are not going to create the object. We are going to create a pointer. So it is just a null pointer. We have declared a pointer of type base. In the second line, in the main right here, we are going to declare an object of type derived, which means the drive class object has been created. Now, at this point, I'm going to initialize the base pointer with the address of the drive class, which means I'm upcasting this object, which means the drive class object is now being casted as the base class pointer. The base class pointer will going to hold the address of this drive class object, which means this address is now being casted, upward casted towards the parent. Now using this pointer, I'm going to access the print function. Remember, print is your virtual function. So at this point, because this is a base pointer, the compiler will going to access this particular version of your print, because again look that this is the pointer and the type of the pointer is base, therefore this particular function will be called. Let's see what's going to happen. The drive class version of show is called. So just focus on this particular concept. We have called a function print with the reference of the base, which means this particular function should be called, but because this is a virtual function, it going to transfer call towards the child, and this particular version of print will be called, which means that this particular version of print will be called. Why this is called? Because this is virtual. Now again, I'm going to call a non-virtual function, that is show, using the base class. Again, the compiler will going to access this particular area, the base class, because the address is of base class. The object has been casted. Therefore, it will going to access this particular class, and this particular function will be called. So this is basically the difference between the calling of a virtual function and non-virtual function. Always remember that if you are calling a virtual function, the virtual function will going to pass control to the drive class, and the definition that is provided by the drive class will be executed. And whenever you are going to call a non-virtual function, it will be called from the base class or from the type of the pointer through which it is being called. Because the type of the pointer is of base, so in this particular case the print function will be called from the drive class and it will be returned as the drive class function, and the show function will be called from the base class. And you can see that the output on your screen would be the base class function. Because it was in print, because print was a virtual function, so the control is transferred from the base class towards your drive class. So always remember, whatever the type of the pointer is, and if it's a virtual function, always remember the another part will be executed, which means if the type of your pointer is base, the drive class function will be executed, and if the type of your pointer is of drive class, you will experience that the base class function will be executed if it is partial virtual. But in the case of pure virtual, you can easily observe that always the drive class version will be executed because it's a pure virtual function. It does not contain any definition, and the definition is being overridden by the drive class, which means the definition is at the drive class. So whenever you are going to call the virtual function from the base class, from the pointer of the base class, you will observe that the version of child will be executed always. So that is basically the concept of using the base class. So the runtime polymorphism is achieved only through a pointer. Remember, you cannot access a virtual function using the dot operator. The base class pointer can point towards the object of the base class as well as the object of the drive class. For the non-member functions, it will point towards the members of the base class, and for the virtual functions, it will always point towards the drive class. So as we have discussed that the base class pointer will contain the address of the drive class, and whenever we are going to call a non-virtual function, it will be executed from the base class, and if we are going to call the virtual function, it will going to execute it from the child class. So the control will automatically be transferred towards the child. So if we have multiple objects of drive class, then which particular object will going to execute? It will depend on the address that is passed to the pointer. So whatever address is passed to the pointer, it will decide that which particular object will going to respond whenever the virtual function call is made. I hope the concept is now very much clear. You can write the same code on your ID and try to execute at once so that you can easily understand the concept. And if still there is some confusion, you can contact me and we can further discuss on this particular example. So this is basically the concept, the memory mapping, that how the memory is been mapped. So this is one of the snapshot of your memory in which we have shown the virtual table for the base class, and similarly we have the v table for the drive class, and you can see that the function definitions are provided in both the class, but which particular version of the function will be called will depend on your pointer. And in the case of the non-virtual function, it always points towards the type of pointer, and it will be executed from the class that belongs to the type of that pointer. And in the case of virtual function, always remember always the opposite part will be executed, which means if the type of your pointer is base, the drive class version will be executed, but this is only for the virtual classes, virtual functions. Okay, let us move towards the concept of this is the simple explanation what we have discussed right now. We move towards further to the abstract class. Let us see an example. I'm going to declare animal as a class, and we all know that animal is an abstract class, which means in the real world we cannot find any object of type animal. We can see a cat, we can see a dog, we can see a mouse. They all belong to the type animal, but we cannot see or we cannot observe any object of type animal itself. So animal, it is basically an abstract class, which means the this type of object does not exist in the real world. Similarly, for example, vehicle. Vehicle is an abstract class. We can see a car, a truck, a motorbike, a bicycle. These are all type of vehicles, but we cannot see an object of type vehicle. Similarly, human. So human is an abstract class. I hope it is clear. So for example, we have declared animal as an abstract class, and in public I'm going to create virtual function sound, and I have declared is at 0, which means it's a pure virtual function. So then we have the rest of the definition and the class is closed. Now I'm going to create another class that is cat inherited with animal, and I'm going to override this particular method. Whenever I'm going to override the virtual function, I need to remove the virtual from I need to remove the virtual keyword from the definition. The signature must be same because I am overriding the method, and I have added the sound of the cat in this particular class. And now we then we have the another the definition, the remaining definition of the class. This class is closed. Now move towards the main, and in main I'm going to create class cat, and whenever I'm going to play like c dot sound, because this is a normal function, normal member function. So for class for class cat, it's a normal member function. It's a non-virtual function. No virtual keyword has been placed here. So whenever I'm going to call the function sound with the reference of an object of cat, it will going to refer this particular class at this point, and the function will be found right here, and it will going to execute this particular method. So which means I'm going to create the object of class cat, because cat is not an abstract class. This class does not contain any method with the keyword virtual, so it is not an abstract class. What about animal? Now when I've called c.sound, it's okay, it will be called, and it will be called from this particular area. But what if I'm going to create an object of type animal? So you can see that it's an error. Why it's an error? Because animal is an abstract class. You can compile this code and you can see that the compiler will going to throw an error. It's going to throw an exception that animal is abstract, which means you cannot create an object of type animal because it's an abstract class. Why it's an abstract class? Because it contains an abstract method. This is an abstract method, a method that is only declared and not defined. And because it's a virtual, pure virtual function, it is mandatory for any class that derives from class animal that it will going to override this particular sound function, this pure virtual function. We're going to override so that the object of the drive class can easily be created. But for example, if the drive class also omits the definition of this pure virtual function, you can see that the drive class will also become abstract just like its parent. I hope this is clear. So we move towards the summarization of today's lecture. So what is basically the virtual function? This is basically the ability to structure our code in such a way that the control can easily be transferred from parent to child, and this is a way through which we can say that newly derived class will automatically work with the our older code without any modification, because whatever modification we want to do, we are going to perform that modification in my child class. And it is not mandatory to create the object of the child class, because whenever we are going to call the virtual function with the pointer of my base class, the old implementation, the call will always be deviated towards the drive class, and the newer version will always be executed. So in that way we can say that the newly derived class will automatically easily will going to work. It will be compatible with the old code and without any modifications toward in the old class. These functions are normally called using pointer. They are never called with the object. It is mandatory for the drive class to override the parent function, the virtual parent function. It is mandatory for the class. Otherwise, the drive class will also become an abstract class. So this is all for today. I hope the lecture will going to help you understanding the concept of virtual functions. We will meet again in the next lecture, in which we are going to discuss the concept of virtual destructors and different type of relationships that can be easily created within the classes. So thank you for listening. Goodbye.